How do you think, which of the following objects we could not break after the nitrogen freezing? A log bar, the grass, the meat, a balloon. 10 seconds to think, write your comments below the video. Could you imagine? It's grass. Unpredictable. All the experiments are gathered in this video. It will be interesting.
So you're watching? Hello friends! Not so long ago we made tons of shorts with liquid nitrogen. We have made our child dreams come true, we have frozen different stuff, and I hope that you have enjoyed as much as we have. If somehow you missed the opportunity and didn't see those shorts, take your time and check it out. Here we go, and first of all let's get started with some random number of facts about liquid nitrogen. 5 seconds and don't switch the channel. So, boiling temperature of liquid nitrogen is minus 195 degrees C, so you can cook your spaghetti there. So, liquid nitrogen is not suitable for cooking, but it is suitable for medical application, for cooling different stuff. It is very useful thing.
We have frozen a piece of meat. A piece of such dimensions was freezing for about 30 minutes, but then, at deep minus temperatures, it became brittle. Try breaking a piece of meat from your fridge. Write in comments, was it the same brittle? A rose. No one expected it will break down into small pieces. It was amazing.
Nitrogen itself is a very strong molecule. It is made of 2 p and 1 sigma bond. Its bond energy is around 900 kilojoules per mole, and it means it is very hard to break. In food industry, the nitrogen gas is used as preservant. In chemical industry, nitrogen is mainly used to produce fertilizers. On the first stage, it needs to be converted into ammonia, and it takes 300 degrees of C and pressure around 200 atmospheres. In daily application, nitrogen is used as inert gas. For example, it helps to prevent food from oxidation, and that is because nitrogen is non-reactive at normal conditions. And some basic school chemistry facts. Did you ever know that air which we breathe in is 70% made of nitrogen? So basically it means that every breath we take is mostly made of nitrogen and not oxygen. By the way, Nikolai, how to make liquid nitrogen?
The liquid nitrogen is produced by 3 methods: membrane, absorption, cryogenic. The most widely used is the cryogenic method. The liquid nitrogen is produced by this method by aerocompression and further throttling it. In this way, they produce liquid mixture of oxygen and nitrogen. Then this mixture is being separated by means of distillation.
Any thoughts how the rubber will react on freezing? Oops! Did you know the liquid nitrogen starts to boil when you put an object in it? The reason is that it starts to boil when contacts to a relatively warm body. How to understand the object is frozen enough? There is no more bubbling. The experiment with the bottle was the most dangerous one. Please don't try doing it at your own. The water is poured into the bottle. Then the nitrogen is added. When you turn the bottle upside down, the nitrogen vaporizes, producing 700 parts of gas to 1 part of liquid. This causes a reactive force. The bottle flies away.
An interesting fact: from 1 liter of liquid nitrogen, 700 liters of gas are produced. It makes it unsafe to store the liquid nitrogen in a closed vessel. I will tell you how to store and transport the liquid nitrogen. For storing and transporting big volumes of the nitrogen, the specific cryogenic pressure vessels are used, and small volumes are stored and transported in dewar flasks. Dewar vessel is designed for long-term storage of substances at elevated or lower temperatures. Dewar vessel is a thermos with a small neck and vacuum insulation to reduce heat loss. In the same way, biomaterials are stored in cryogenic vessels. Dim, could you tell us how the bodies are being frozen?
Sure! Indeed, the subject of freezing living organisms and bodies is widely mentioned in mass culture, and many of us have seen such the movies like Alien, Terminator, where the bodies were frozen. Let's check. An idea of freezing the bodies in liquid nitrogen is really interesting and promising, but there are practical issues which prevent implementation it in real life. One of them is related to low heat capacity of liquid nitrogen. The thing is that in order to freeze even a small piece of material, a significant amount of time is required. For example, freezing of a barn log will take around 25 minutes. We observed it during our experiments. Even freezing of a small rose took around 3 to 5 minutes. Imagine how much time is needed to freeze a body of an adult person. So what is the problem, you may ask? The problem is that at freezing process, the liquid contained in the body tissue, when being frozen, damages the tissue which is still not frozen. In order to overcome this barrier, specialists are stopping a heart before body freezing, so it won't move and damage itself. Scientists are developing other solutions for this challenge. But there is another problem related to defrosting. Imagine a frozen body at -196. How much time is needed for it to get defrosted, if this is a suitable terminology? A defrosting process of any object starts from its surface, and the thing is that during defrosting time of a person's body, the outer layers of it will start to die. And this is a second challenge. The glove was also made from rubber. Just listen to the sounds of its breakage. A few more breakage sounds. When a bottle filled with nitrogen with a balloon on it is placed into a glass with nitrogen, no vapors are being produced. Nothing is being vaporized. but placing the same bottle into the hot water makes the nitrogen vaporizing, filling up the balloon with gases. The same effect could be observed even when warming up the bottle by your hand. Just kidding with frozen balloons. Oh no, what a busters! Here we wanted to repeat a trick of mythbusters. Is it really possible to open a PADLOCK by means of nitrogen? Yep, it worked. I could not imagine that there are such the issues with bodies freezing in the liquid nitrogen. Write in comments, have you ever thought about it? Have you ever dealt with the liquid nitrogen? It will be interesting to know and discuss. In the meantime, I will tell you about how we purchased the liquid nitrogen for our experiments. Each person of Science Guy's team thought that buying the nitrogen will be a real challenge. That we'll need to pass the safety test, or at least to fight with the cyborg from Terminator 2. It turned out it was not the case. Watch the video. This is how a Devar flask is filled in with the liquid nitrogen fed from cryogenic vessel. The process is charming. At this stage our first meeting with the liquid nitrogen has finished. We really loved it. So if you have any ideas, comments, if something was done in the wrong way, just let us know. Give us your feedback, we'll gladly repeat what is needed. By the way, subscribe to our channel, like the videos, this is really important. Our project is young, we need your support.